Have you ever stared at one of those big, chunky physics questions on an exam paper and just felt your brain freeze up? Yeah, we've all been there. Well, today we're going to change that. We are going to deconstruct a classic AQA bungee jump problem, piece by piece, to show you exactly how to get every single mark. We're going straight to the source, the exam question, and most importantly, the examiner's mark scheme.
So, our playground for today is this theme park ride. This is actually the basis for question 6 on the AQA GCSE Physics paper. And it's a brilliant problem, It tests a little bit of everything, energy stores, forces, and yeah, some pretty important calculations.
All right, let's set the scene. The exam tells us we've got a person in a pod, and that pod is hooked up to 2 bungee cords that are already stretched. In a moment, it's going to be launched straight up. It's the perfect setup for examiners to really dig into your understanding of how energy moves from one form to another. Now, before we even dream of touching a calculator, the very first step is to pull out all the clues the examiner has given us. We've got the extension, the spring constant for each cord, the mass of the pod, and the gravitational field strength. Think of these as the ingredients for our recipe for success. Okay, let's get into it with part 1. Exams often kick off with a nice, straightforward 1-mark question like this. It's kind of like a warm-up, just to check you've got the fundamental concepts down before we get to the really heavy listing. So, the question is pretty simple. As you pull back and stretch those bungee cords, which energy store are you actually filling up? Just take a second to think about it. What do we call that energy you store in something stretchy? And the physics principle we're looking for here is, of course, elastic potential energy. It's that energy that gets locked and loaded into a spring or a rubber band or, you guessed it, a bungee cord the moment you stretch it or squash it. Now, here is a golden nugget of exam advice. This phrase you see on the screen, it is pulled word for word from the AQA mark scheme. Just writing elastic potential energy gets you that mark. It's that simple. Know the right term. Get the point. All right, now for the main event. This is the big one, the 6-mark calculation question. This is the kind of question that really separates those who kind of get it from those who really get it. Our mission, figure out the maximum height that pod can reach. So the challenge is laid out. We've got our numbers, we've got our mission. And remember, for a beast of a question like this, showing you're working is absolutely crucial. It's not just good practice, it's how you can scoop up marks along the way, even if you make a little slip up right at the end. To nail all 6 marks, we're going to follow a crystal clear 6-step plan. Think of it like climbing a ladder. Each step you complete correctly, that's another rung, another mark in the bag. So let's start climbing. Let's get on that ladder. Step 1 is just stating the right formula for elastic potential energy. Step 2 is plugging in the numbers for a single cord. We do the math, and we get 23,520 joules. And just like that, that's 2 marks down already. See? Not so scary. Okay, step 3. Now, this is a classic trap. It's so easy to forget this bit. The question clearly states there are 2 bungee cords. It's such a simple detail, but missing it will cost you a mark. So we're not going to miss it. We double our energy, giving us a grand total of 47,040 joules. And boom, that's mark number 3. Now for the real physics magic. This is for marks 4 and 5. We make a really important assumption, that all of that stored elastic potential energy gets converted perfectly into gravitational potential energy when the pod flies up. So we set our total EE equal to the formula for GPE. Then it's just a little bit of algebra to rearrange the equation to find H. And here we go, the 6th and final mark, the grand finale. We just need to run the numbers. That's 47,040 divided by 240 times 9.8, and our final answer is 20 meters. 6 steps, 6 marks. Job done. So our calculation gives us a perfect answer of 20 meters. But let's be real, physics in the real world is a little messier, isn't it? It's never quite that perfect. The final part of this question is all about testing if we understand why our calculated answer is just an ideal, best-case scenario. This is a 2-mark explanation question. Why, in reality, won't the pod actually hit that 20-meter mark? This is all about knowing where that lost energy goes. And of course, it's not really lost, is it? It's just transferred into other, less helpful energy stores. And what's really interesting here is that the mark scheme gives you a lot of options. You've got several ways to get the marks. You could talk about air resistance fighting against the pod. You could say the energy transfer just isn't 100% efficient. Or you could use broader terms like energy is dissipated or transferred to the surroundings.
Any of those will get you the points. Okay, let's zoom out and put this all together. By breaking this problem down into tiny, manageable chunks, we can see exactly what the examiner wants at every single stage. It's not just about getting that final number. It's about proving you understand the physics concepts every step of the way.
And look at this. This one table is basically your perfect revision tool for this problem. It links the question number directly to the core physics idea being tested, and it shows you the exact answer the mark scheme is looking for. This right here is the blueprint for getting full marks.
So, the biggest takeaway today isn't just the answer to a bungee jump problem. It's the method, right? It's the whole approach. How can you take this same strategy, finding the clues, breaking it down into steps, and always thinking, what does the examiner want to see, and apply it to every other tricky problem you face? Because that is the real secret to turning those terrifying questions into easy marks.